this video we'll be looking at finding electric field at, or you can say electric field near a charged conducting surface. Okay, conducting. Okay, in the previous one we have found it for that plain sheet of charge. Okay, so we have a conducting surface. Okay, we'll be using that same formula. Okay, E dot D equal to Q enclosed by epsilon naught. Okay, suppose this is a conductor. Okay, let's say in shape of a sphere. Okay, we need to find electric field, let's say at this point. Okay, near this. What will be the direction of electric field? Okay, the direction will be always outward. Let's say EP, or you can say yes. Okay, uh, the charge that is enclosed, okay, that will give what? Flux Q enclosed upon epsilon naught, right? And this E dot dA, right? This will be equal to E dot dA, right? So, firstly, we will look at what is Q enclosed here. Q enclosed is actually phi is equals to Q enclosed is what? It is, if it's, let's say, surface charge density is sigma, then it is sigma into A, right, upon epsilon naught. Okay, if this whole area is A, right? Now, if you see that this E dot dA will be what? It will be E into this dA. Integration of this dA will give what? It will give the total area of this conducting sphere, which is actually A, right? So if we equate all these two, then we'll get this. Okay, A gets cancelled out. That is E is equal to sigma upon epsilon. This is what? This is electric field near a charged conducting surface, right? And for the that sheet of charge, we have found it sigma upon 2 epsilon naught. Okay, these two are different terms, right? Thank you.